In the previous video, I showed you how to find all the prime numbers between 1 and 100. And by the way, 0 is not a prime number and 1 is not a prime number. Your first prime number is 2. And by the way, if 2 is a prime number, you can never ever have another even prime. Because the minute you have an even number, let's say 30, then you know immediately you can divide 30 by 2. So therefore 30 cannot be a prime number. If you have, I don't know, 30, 32, well 32, that's immediately you can divide by 2. So 2 is the only even prime. You cannot have another even prime number because immediately it would divide by 2. Okay, and if you don't know what a prime number is, you learn to use the internet. Punch into a search engine of some sort. Punch in the word prime and the word definition. Definition means precise meaning of something. So if you don't know, if you want to know something, just or maybe if you don't know what a factor is, then punch in factor and then definition. Definition means the precise meaning of something. So if you punch in prime definition, then something like this would come up, and well, it might vary slightly, but overall, when you get an answer, what is a prime number? If you punch in prime definition, you might get something like this. Learn to analyze what they're giving you. So learn to actually read it and try to analyze what's going on. A prime number is a number that can be divided exactly. So divide exactly. So this bit here is quite hard to understand. Divide exactly. Okay, leave that for the time being. Only sounds quite important. So only by only one and itself. So if you look at if you look at, let's say, 17, you see the only way you can break up 17 is 17 and 1. This is or 1 and 17, but we're not going to look at this. Just look at 1. So look at this here. A prime number. This is what you want to know here. This is what you want to know. A prime number is a number that can be divided exactly. So this bit here, divide exactly, it's a bit hard to understand. But from experience, because I've done this a long time, I know that divide exactly means, well, if you look at this here, 17 divided by 1, that will give you a whole number. That's what it means, divide exactly. Or if you look at 17 divided by 17, that will give you a whole number. Divide exactly by only. Only means you cannot find another example. Whereas if you look at let's say 12, you could divide it by you could break it up as 12 and 1. That's good. But then you can also do it like this, 3 and 4. But then it's saying a prime number is a number that can divide exactly. Only meaning only one by only one and itself. So this is 1 and this is itself. But if you look at 12, we found another example where you can where you can actually, if you look, it's saying a prime number only divides by 1 and itself. Well, here if you look at 12, 12 is not a prime number because I can divide by 3 and it will give me a whole number. Or I can divide by 4 and then it will give me a whole number. So when you don't know something, type in that word and then definition. The word definition. Definition means precise meaning of something. And once you've got the answer, try to sit there and analyze what's written. So try and pick out important words. Look, this only is very important. And maybe exactly, divide exactly. Divide exactly. Okay, this bit, unless you have experience, you might find this bit hard to understand. Okay. So anyway, you could try. Well, what is a factor? A factor. Maybe you can type in the word factor and then definition. So a factor of a number. So I would pick out off. That's quite important, because if you say can I have a piece off your cake, it means can I have a piece meaning a piece off your cake, it meaning that piece there. Hang on, I'm drawing this badly. This piece here comes from a whole. This piece here is part of a whole thing. So a factor of, meaning this factor is part of this whole thing here. So can I have a piece of your cake? Well, piece is a part of a whole thing. So this is a part of a, well, the number here is made up of this thing here. Okay, we'll divide exactly into it. Now, divide exactly, this bit is quite hard to understand, but because I've done this for a long time, well, divide exactly means you can divide it by a whole number. You divide it by something, and then it gives you a whole number. Okay, this bit here you just have to accept. So a factor is a factor of a number will divide exactly into it. So for example, if you look at 21 here, it's made up of a 3 times a 7. So what it's saying is a factor of a number. So this, well, 21 here is made up of 3 times 7. Well, this here is a factor because this is off. It means it's part of this whole thing here is off of a whole thing here, and then divide exactly into it. So 21 divided by 3, it will give you a whole number, and then or you can say 21 divided by 7. That, you see, this is also a factor because it divides exactly into it. So it means that if you get 21 divided by 7, it will give you a whole thing. Okay, or if you look at 56 here, 56 is made up of an 8 times a 7. You see, 8 is a factor and 7 is a factor. Okay. Well, if you don't know something, punch in that word and punch in definition. Well, why are primes important? Well, if I give you this here, in order to have two fractions, you have to get the two denominators to be the same. And the way you would probably do this is times top and bottom here by 2, 3, 4, 2, 3, 4, and then times top and bottom here by 1, 5, 6, 1, 5, 6, and then you can be sure that that this denominator here is the same as this, and once they're the same, then you can add the two. But the thing is, times in top and bottom here by 2, 3, 4. 2, 3, 4 is a lot of work. It's a big number. The thing is, it will still work if you times top and bottom here by 3, okay, and then over here times top and bottom here by 2. The question is, by looking at these two numbers, how is it that I know that 3 works and 2 also works? How is it that how did I know that I can use a 3 and a 2? You see, this is where prime comes in. If you look at this 1, 5, 6. Okay, don't worry about this bit. Just watch for the time being. Okay, how? Just watch for the time being. So 1, 5, 6. I'm going to break this up as, because this is I can see it's an even number, so I can break it up as a 2, 7, 8. Okay, and then I can break this up as a 2, 3, 9. And then I can break this up as a 3, and 13. Okay, so again, don't worry about this. Just I will explain this at another time. But for the time being, just watch this. All these are actually primes. All these are prime numbers. Now I'm going to do the same for 2, 3, 4. So I can break this up as a 2 times a 1, 1, 7, and then I can break this up as a 3, 3, 9, and then I can break this up as a 3 and a 13. Okay, again, don't don't worry about this. Just watch. It can be done. That's all that I'm illustrating. So here, 56. 56 is made up of 2 times 2 times 3 times 13. 234 is made up of 2 times 3 times 3 times 13. Okay. Now, because I'm trying to find something in I'm trying to get the two denominators to be the same. It means that I'm trying to find a number where 156 and 234 has something in common. There's a number that the two will have in common. That's what I'm trying to do. So by breaking those two numbers up as a product of primes. So product means one thing times another. So for example, a product of A and B, it means A times B. Don't worry about this. A ratio means a ratio of A to B basically ratio means divide, product means times. So I can write 156 as a product of primes. You see, all these are primes, and they're all multiplying each other. That's why you can say a product of primes. Okay, don't worry about it. So here we're here at the moment. So now you look at what they've got in common. Look, you've got this in common, you've got this in common, you've got this in common. So you can rewrite this as 156 equals. Let me write as this, and then merge all the others together. 2 times 3 times 13. I can visualize it like that. 2, 3, 4. This I can visualize it as a 3, and then basically merge these together here. Okay, so it will be, again, don't worry about this. Just watch. You don't need to understand this. Okay, now so here this equals 2 times this here would be 6. So it's a matter of 6 times 13. What's 6 times 13? Well, 6 times 12. 6 times 12 is 72. So this will be 78. Okay. This would be 3 times 78. So I know that, you see, if I get this times this and then this times this, then I will get the same. Well, that's how I know by looking at this here. And if you ever heard of the greatest common factor, well, this will be the greatest common. Well, don't worry about this. Just know that prime numbers are useful for us to analyze numbers. Okay.